Okay, so let's look at some of these first ones. Um, so when you're doing the product rule, when you're doing the product rule, um, obviously, I say obvious, you use it when you are multiplying two things. Let me grab these first few. Um, don't always dive straight into the more complicated derivatives, that being anything other than power rules. So before you just start product rule or quotient rule or chain rule, which some of these you may not even know what they are, but there are several different techniques for differentiation. Before you just dive into them, stop and think for just a second. Is it possible to avoid doing this rule? Could I do a little bit of algebra before I start the calculus? So for example, if I gave you something like x cubed times x minus 7, or I'll say x squared minus 7. That is currently a product. It is x cubed times x squared minus 7. So product rule can be used, but it's easier to just distribute the x cubed and turn it into a nice power rule derivative where you can bring down the exponents. So we've eliminated the product just by doing a little bit of algebra to make the derivative significantly easier. So before you just dive straight into the calculus, stop and think for just a second, is there a way that I could avoid the harder derivative? So I'm looking at number 10. It's 2x squared minus 5x times e to the x. And because e to the x is a different type of function than this one, the product rule is unavoidable. You could distribute e to the x, but if you distribute e to the x, you would have 2x squared times e to the x minus 5x times e to the x. And what you've done there is you've now created two product rules. We would have to do the product rule with 2x times e to the x, and then another product rule with 5x times e to the x. And so we definitely don't want to distribute. So the product rule is, for this one, of the more complicated derivatives, it's probably the easiest. You simply do the derivative of each piece one at a time. So we have the derivative of the first one is 4x minus 5. Leave e to the x alone. Then we add, we leave the first one alone, 2x squared minus 5x. And the derivative of e to the x is e to the x. And you're done. Do the derivative of one piece at a time. Good. Number 11 is almost identical to this one, to 10, except I would start by changing 2 root x. Actually, you know what? I can't decide if I want to do this. I'll do it. Let's change 2 times the square root of x to 2x to the 1/2. And then the e to the x is just going to hang on out there. So there's my g. Now my derivative, g prime. Again, we are multiplying two things with x. It's this thing times e to the x. So I start by doing the derivative of the first. Derivative of 2 is 0. Bring down the 1/2. Half of 2 is 1 times x. Subtract 1 from 1/2, you get negative 1/2. So I just did the derivative of 2x to the 1/2. I'm going to leave e to the x alone. Now I'm going to leave my first one alone. 2 plus 2x to the 1/2 times the derivative of e to the x, which is e to the x. And you're done. Questions, comments? Okay. What about 16? What'd y'all do for that one? Did you do anything? Yes, this is one where I would not do the product rule. And this one foils quite nicely because they are conjugates. These are the same types of functions. They're all power functions. They're all u to a number power. So because of that, I can distribute or expand this, and it cleans up very nicely. If you recognize that these are indeed conjugates, then all I have to do is u times u and square root u times square root u. And this function, h of u, cleans up to u squared minus u, and now I have a very easy derivative. I'm not going to do product rule on this one. I'm going to distribute first and then do product rule. All right. Now, product rule is not wrong. If you want to do product rule, you're more than welcome to. But in the future, we will get to a point where we don't just find the derivative and look at it. We find the derivative, then we have to use it to answer bigger questions. And I would much rather work with an equation of 2u minus 1 than the equation that results when you do the product rule. So the product rule is going to give you something really ugly. 17 is kind of in the same category. These are all the same types of functions. V cubed, v to the first, v to the negative fourth, v to the negative 2. They're all power functions. It's not a mix of exponential and power. So for this one, it's not going to expand as sexily as number 16 did. It's not quite as nice, but I think expanding might, I don't know, what do y'all think? Expand or product rule? I'm thinking expand, although I'm not sure if the trade-off is going to be as beneficial as, well, I definitely know it's not going to be as nice as 16 was. So let's expand this. So this one we do have to be a little bit more careful with our expansion. J of v. What? I don't know how they come up with these weird functions. J of v. V cubed times v to the negative 4, you add those exponents. That'll be v to the negative 1. V cubed times v to the negative 2 would be v to the positive 1. You add those exponents. Minus 2 times v to the 1 minus 4 would be v to the negative 3. Negative 2 times 1 is another negative 2 times, and then 1 minus 2 is negative 1, v to the negative 1. And I guess that's kind of nice because I can combine those two v to the negative 1s. We have like terms. And so I'm left with negative v to the negative 1 plus v minus 2v to the negative 3. And then we can take that and we can do the power rule. J prime of v, bring down the negative 1. Negative 1 times 1 is positive 1. V to the negative 2 plus the derivative of v is 1. Power rule this one. Negative 3 times negative 2, positive 6, v to the negative 4. Yeah? Good, bad, ugly. And then 24 is very similar to the first two. We have an exponential function with power function, so we're not going to avoid the product rule here. And distributing is not going to help either. I am going to make one little change, though, because p root p scares me. I'm going to change p root p because as it is written, that is itself a product. And if you don't change the way that's written, you would have to do a product rule inside the product rule. And sometimes derivatives do get layered like that. You have to do multiple derivative techniques. I don't want to do that, so I'm going to change p root p to p times p to the 1/2. And if you multiply two things, you add their exponents, so that can just be rewritten as p to the 3/2. Now I just have a power rule for p to the 3/2 instead of the product rule for p times square root p. Ah. Okay. So now I do the product rule. My derivative, dy. I'm going to go Leibniz notation here because they have y equals. So I'm going to do dy dp. This is a function of p, not a function of x. So don't write dy dx. This is the derivative of y with respect to p would be, and then my product rule, we're going to do the derivative of e to the p, which is e to the p. Leave the second one alone, so that'll be p plus p to the 3/2. You go up there. Plus, leave the e to the p alone. This time I'm leaving it alone. And now the derivative of the other one would be 1 plus, and then the power rule for p to the 3/2 is bring down the 3/2, p to the 1/2 power, and we are done. How's life? Questions, comments? Yeah? What about? Oh, that was all 5 of them. So that was all 5 of that first section. Okay, so now 34 and 35 are asking for not just the first derivative, but also the second derivative. So you have to do the derivative, then the derivative of the derivative. And so if you haven't tried those yet, I'm going to give you a minute. I want you to try those. And then after you have a minute to do 34, I'll show you how I would do 34. Was? It could be. It could be difficult. Could be. There's one thing you can do to make it a little bit easier, not to be confused with easy, but just a little bit easier. So we're finding f prime and f double prime. The first derivative is nice. It is a product, and there's no way around that. So derivative of x cubed is 3x squared. We will leave e to the x alone, plus leave the first one alone, x cubed plus 1, and the derivative of e to the x is just e to the x. So there's our first derivative. Did we hammer that one out okay? Good. What about the second derivative? What do you see? Huh? Yes. Factor out the e to the x before you dive into the derivative. I know a long time ago, the video for product rule featured a problem like that. Did I do that in the newer one? So it was in there? Okay, good. If you dive straight into the second derivative, this is what I was alluding to earlier. If you don't stop and think about algebra, you may be skipping a way to make the problem significantly easier. Because right now, if you jump straight to the derivative, you've got a product rule plus a product rule. You're going to have 4 different terms in the final answer. Or you could recognize that there is an e to the x they have in common, and we can factor out the e to the x. And when you do that, you're left with a 3x squared plus x cubed plus 1. And now we have a single product that's just as easy, maybe a tiny, tiny bit more difficult because there's 3 terms here, but it's almost identical to the first problem. So now we have a nicer second derivative. So f double prime derivative of e to the x is e to the x. We will leave the second one alone. Plus leave the e to the x alone. And the derivative of my second term is 6x plus 3x squared plus 1. How's life? And we'll stop there because we're not doing anything else with that derivative. We're just looking at it and thinking about how pretty it is. Yeah? Yes? Mm-hmm. Uh-oh, I messed up, didn't I? That's not right. Is that why you're asking? Yep. The derivative of 1 is 0, not 1, right? So that shouldn't be there. Whoops. Cranial flatulence happens to all of us. What do we think? You want to do the next one? Go over the next one? What was the next one? Where is he? This one. I don't know if this one was bad. I am going to point something out that may not be a bad idea for you to add to your memorization bank. Have y'all already memorized your trig derivatives? What? All right, so let's look at 35. Separate these. Do you want to change the square root of x to x to the 1/2? Do you want to write that down? You can if you want to. You can if you want to. We will do the product rule. F prime. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. Leave e to the x alone, plus leave the first one alone, times the derivative of e to the x. And then, for my second derivative, we'll just factor out the e to the x. Does anybody want to factor anything else out, or just the e to the x? Okay, we'll just do the e to the x. You have other options, but I don't think the other ones are going to make it any easier. If anything, it might make it harder. And then my second derivative, f double prime, the derivative of e to the x. Leave the second one alone. Plus, leave e to the x alone. And the derivative of the second one, 1/2 times 1/2 is 1/4. Watch the negative. Negative 1/2 minus 1, negative 3/2. And then the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And we'll stop there. Okay? Okay, something for future reference. We could have done it here because there is a square root of x. However, the fact we had to go to the second derivative probably means the way we actually wrote our answer to this would be the easier way, because we did have to do the next derivative. Let's put phones up, people. When you're doing the derivative of the square root of x, we have been writing it as x to the 1/2, and then we do the derivative of that, where the derivative of x to the 1/2 ended up being 1/2 x to the negative 1/2. And we write it that way because it follows the same pattern as every other power rule we do. That does simplify to 1/2 times the square root of x. Like if you wanted to rewrite that in radical form, that's what it would end up looking like. And it probably would not be a bad idea for you to just remember that the derivative of the square root of x is 1/2 times the square root of x, and jumping straight to that format instead of marching through x to the 1/2 power. Now, like I said, the previous problem asked for a second derivative, so the fact that we had to keep going after the first derivative means the power rule approach is probably the better way. But if all you're doing is the first derivative, it would probably be in your best interest to just kind of memorize this and just slap down 1/2 root x. And I promise you, there is a day coming, and it's not until next semester, but a day is coming where your ability to just know that 1/2 root x is the derivative of root x will be hugely beneficial. So even if you're not actually writing it down right now as you do derivatives, there will be a day where you need to recognize that 1/root x structure for the derivative of square root of x. Good, good? Good, good. 40, I don't think it's too bad. 41 is an interesting one. Let's see what y'all can do with 40 and 41. Have we already tried 40 and 41? Maybe, maybe not. All right, here comes my 40. Equation of a tangent line. Anytime you see equation of a line, you want to think point and slope. Then think about how you're going to get those two pieces of information. They explicitly gave you the point, and the slope is from the derivative. So we had to find the derivative and then plug in 0, and you should have gotten a slope of just 2 for the tangent. Now, because we're going through the origin, you could have just written this as y equals 2x. You don't have to put y minus 0 and x minus 0. I just put it there just because I always do point slope form, and I think it looks better. And then the normal line, you just do the negative reciprocal of the slope. How do we feel? I forgot to bring WD-40. I meant to do that today. Any questions about product rule so far? No? The normal is perpendicular to the tangent. So everything's the same except your slope for the normal is your negative reciprocal. So there's really no extra work for the normal line, other than the fact you have to write it down. But once you find the tangent slope, the normal slope is pretty easy to find. Good, bad, ugly? All right. What about 42? What is 42 asking? Where'd it go? Here he is. Is that? Nope. It's a multiple choice question. That gives us options that I might ignore. But it asks for the value of x where x times e to the x has a horizontal tangent line. I don't think we have answered a question like this yet. What do you think we'll have to do? One good thing about calculus is 97% of the class is either derivative based or antiderivative based. So next semester, probably towards the end of this semester, we're actually going to do derivatives in reverse. I give you the derivative and you work backwards to find the function. That's called an antiderivative. So if you're wondering what to do for any particular problem, first try to decide, do I need the derivative or the antiderivative? Since you don't know what the antiderivative is, it's a pretty safe bet that we're going to be doing derivatives. And anytime you see the word tangent, you should immediately think derivative. So I'm going to need to find the derivative, which again is a product rule, and this one's a really nice one. The derivative of x is 1, leave e to the x alone, plus leave the x alone times the derivative of e to the x. So there's my tangent. But how would I use that? I'm sorry, that's not my tangent, that's my derivative. How would I use that to find out when the tangent is horizontal? Set equal to 0, because if a tangent is horizontal, the slope of a horizontal line is 0. And if the slope is 0, that means your derivative must give you 0. So every problem we've done up until this one, we were given the x coordinate and we used the x coordinate to find the slope. This time we're given the slope and we use the slope to find the x coordinate. And places where the tangent is horizontal are very, very, very significant. We're going to be setting derivatives equal to 0 for a long, long, long time. As a matter of fact, we're going to do it so much that a lot of times you'll do it out of habit, even if you don't need to. Like you'll find the derivative and you'll just kick into autopilot, set equal to 0 and solve. So we need to channel our algebra skills. How would you solve this? Good, I would factor out the e to the x. So e to the x times 1 plus x equals 0. And when you solve by factoring, you need each of them to equal 0. Or I guess you need one of them. So we'll start with e to the x. When does e to the x equal 0? And when does 1 plus x equal 0? The second one's easy, -1, which that's going to be the answer. But why did they ignore e to the x? When does e to the x equal 0? It doesn't. Remember, the graph of e to the x is always above the x-axis. It never does hit the x-axis. There's no solution there. So x equals -1 is the only place. And we call that a critical point. It's so important. It has a name, the critical point. You don't even know that yet. We're going to talk about that in more detail later. But places where the derivative equals 0 is a critical point. Are we happy? It's almost Friday. Cheer up. No? Yeah. Okay. Okay, where's another good one? So that graph, what is this? What is that? What is that? Holy cow. Does this look fun? You have a big old table of values. And well, there are actually under 56. There were like 4 parts. There was an A, the B, C, and D parts. I think I'll use the quotient rule. And so we're just going to do A. And A only has F in it. So we really don't even need but half of this table. The G columns are unnecessary. But this is saying find the value of that. First, can you read that? Do you even know what the command is? Like what we're supposed to do? Find the derivative and then plug in 4. These problems, they're very scary looking, but usually people like these problems better than when they have explicit equations that they have to plug numbers into and do the arithmetic. All right. So let's start with the derivative. The derivative of root x times f of x is, well, it's a product rule. So we have to do the derivative of square root of x, which I'm going to go straight to my memorized form. Instead of saying 1/2 x to the -1/2, I'm going to say 1 over 2 square root of x. I'll leave the second one alone. Plus, I'm going to leave the first one alone. And now the hard question, what is the derivative of f of x? it's f prime of x. We don't know what f is, so the best we can do is just a symbolic, the derivative of f is f prime. You're good? Now, they actually wrote the words at x equals 4. I want to show you another notation just in case you see it. The formal way of doing this is you would say all of this, and maybe I need to put that in parentheses, but all of this, and there is a such that symbol in math, and all it is a big vertical bar. It's like an absolute value bar. Such that x equals 4. Your calculator, if you have played with your Inspires, you will notice that there is a such that bar button somewhere on the left side. People often confuse it with an absolute value bar. It's not an absolute value bar. So we do all that such that x equals 4, which means we just plug in 4. So 1 over 2 square root of 4 times f of 4 plus the square root of 4 times f prime of 4. And how am I going to get f of 4 and f prime of 4? No, we simply look at the table. They give you those values. So 1 over 2 root 4 is going to be 1/4. F of 4. One thing you have to be careful with on these is when you have these huge table of values, it's very easy to accidentally look at the wrong spot and just write down the wrong number absentmindedly. So be absolutely certain you're looking at the right spot. So f of 4 is 16 plus the square root of 4, which is 2. F prime of 4 is -1. And that cleans up to 4 minus 2, which gives you a final answer of 2. How are we? Okay. Yeah. Yeah. Okay. What I want you to do for homework, there are, I think, only 3 more questions on this, and they'll be within the PDF. They'll be on the notes on my webpage, or you can pull up the textbook that I linked on my calendar, or you could sign up for Cengage and access it that way, which you need to try to do. But finish these 3. There is like an 8-minute video. It's a short video on the quotient rule. I want you to watch that also. So I'll link that, and we'll hammer out product and quotient rules again on Monday. Our next test is like 2 weeks away. I'm leaving for Disney World in exactly 2 weeks. I will be gone Friday 2 weeks from now. And we're taking a test right before that. So we'll have 2 weeks before our next test. So our tests are normally not as spaced out as that first one was. What was that, like 6 weeks before we had our first big test? All right, we're done for the day.